sorry for this beginning. I'm Regina Lopes. I'm coming from the Center of Marine Sciences in Algarve, Portugal. So I'm going to talk about marine speciation and two radiations in the Cape Verde Islands. First, I will talk about an example, a remarkable example of marine radiation in cone snails with more than 60 endemic species. And then I will talk about smaller but also significant radiation in keyhole limpets. So this is the Cape Verde archipelago, which is located in the Atlantic Ocean. It comprises 10 main islands and a couple of islets, and is distant from the west coast of Africa about 500 kilometers. It's an oceanic island, was never in contact with the continent. Known geological ages vary between 5.9 and 25.6 million years, and with the older islands here in the eastern part of the archipelago. And these are the cone snails, which are marine gastropods. They are venomous, and they are very appreciated by shell collectors. Only in Cape Verde, there are more than 60 endemic species described that represent almost 10% of the worldwide diversity, which is a lot. So these all Cape Verde endemics have less heterotrophic larvae, which means that they don't have any pelagical larval phase, and they complete their larval development within these egg capsules, and when they are released as young adults, so we do not expect high dispersal abilities. They are all herbivorous because they eat these polycats of different sizes, and these are the typical habitats that you can find in the islands. Usually they are buried only with the siphon protruding, or they are hidden in crevices, which makes their sampling quite challenging. We performed a molecular analysis based on 3 mitochondrial genes over 2,000 base pairs that indicated the existence of 2 main clades, according to shell size, the small shell clade and the large shell clade. We could infer that there were 2 independent colonizations of the archipelago because each clade of endemics has a sister group species that occur outside the archipelago. For instance, for the small shell clade, all these species occur in Algarve, Canary Islands, or West Africa, or the sister lineage of this large shell clade occurs in Canary Islands. We believe that the reason for this amazing diversification is the allopatric speciation, promoted by the reduced dispersal ability of the less heterotrophic larvae, which causes reduced gene flow between distant populations. That's why most of the species show restricted distributions to an island or even to a single bay. We also performed the dating analysis, and that showed that these independent colonizations occurred in 2 different time scales. While the small shell clade, the stem lineage of the small shell clade originated 16.5 million years ago, the stem lineage of the large shell clade occurred much more recently at 4.6 million years ago. These 2 age estimates coincide with 2 remarkable drops in the sea level, which is quite amazing because most of the times sea level drops cause major extinctions, mostly in bivalves. We can see here that given the topology of the Cape Verde bays, which are quite shallow, a drop in sea level increases the area available of shallow water habitat, creating additional opportunities for speciation. A little bit of self-promotion. These studies were based mostly in these 2 publications. Now let's move forward for the next example. Those are keyhole limpets. It's a small radiation, but it's also significant. I will show why. So we focus on the family Fissuralidae and on 2 main genera, Fissurella and Eudora, which are the most abundant in the archipelago. Both genera have separate sexes and have a breeding season mostly between October and November. And they are broadcast spawners, which means that they release the gametes in the water column. We don't know exactly the duration of the pelagical larval phase of each genus, but studies within the same genera indicated a short pelagic larval phase for Fissurella of about 4 days, and a larger PLD for Diodora that can go up to 3 weeks. And morphological studies based mostly on shell characters indicate the existence of 12 species within the genus Fissurella in the archipelago, 7 of them endemic, and 6 species within Diodora, a single endemic. We found some conflicting results between morphological studies and our results based on molecular data. For instance, species delimitation tests agreed on the number of endemics, so we found 7 species within Fissurella and a single species within Diodora, which is okay, but all specimens we collected cluster in the clades of endemics, which means that we didn't find any evidence for the existence of non-endemic species. And we saw previously that morphological studies indicated 5 non-endemic species for each genus, which is normal because these characters, shell characters, usually are quite plastic and can produce misleading results. This is the geographic distribution of the species that we retrieved from our species delimitation tests, and you can see that species 1 is the one presenting a wider distribution, while species 3 and 4 are mostly restricted to the western part of the islands. We are talking just about Fissurella. While there are some species that are restricted to a single island. Diodora only occurs in the island of Boa Vista. We know that both genera are broadcast spawners, so they release the gametes in the water column, and dispersal is mostly determined by ocean currents. So we were quite surprised how come could we have 7 species within Fissurella, given that there are no apparent barriers for gene flow. We know that distances between islands can be as little as 17 kilometers, and even considering a short pelagical larval phase of 4 days, as we think is the duration for Fissurella, that could allow species at least being widely distributed in this area. And you can see that species 1 is only in the island of São Vicente. Why it's not in the other islands? This, considering that dispersal is mostly driven by oceanic currents, we decided to perform simulations to analyze connectivity between the islands. So, using simulations with present-day currents indicated the existence of 3 main clusters of islands that roughly coincide with present-day species distribution in Fissurella. When we increase the passive dispersal to 30 days, which could cover all PLDs that we think that could be, we already get 2 clusters that do not reflect current species distributions. So we believe that Fissurella must have a pelagical larval phase of 4 days or within this range of duration. We also analyzed, so present-day current patterns of ocean circulation seem to promote local retention and explain present species distribution. We also wanted to evaluate the importance of the duration of the pelagical larval phase in species distribution. And simulations indicated that after 4 days of dispersal, a mean distance that a particle can reach is 75 kilometers. When we increase this distance, this passive dispersal for 30 days, as you can see, the distance doesn't increase much, which means that the duration of pelagical larval phase is not the most significant factor affecting and promoting the current species distribution. However, there are questions that remain unresponded. For why Fissurella has 7 species and Diodora did not diversify? So we had to put current patterns of ocean circulation explain that distribution, but do not explain this species asymmetry. So we had to put additional hypotheses back to explain this asymmetry. We analyzed habitats, and we didn't find any significant differences between habitats of Diodora and Fissurella. So we discarded the hypothesis of habitat specialization or niche partitioning. Another hypothesis could be undersampling within Diodora, which is the genus that is less species. However, we put exactly the same sampling effort for both genera. However, we found a significant bias in abundances. While we found more than 300 specimens within Fissurella distributed by 9 islands of the archipelago, we could only find 26 specimens in total for the genus Diodora, and all of them in this island of Boa Vista. So there was a strong bias in the abundances. The third hypothesis would be the existence of increased diversification rates in the Cape Verde Fissurella clade. Indeed, our macroevolutionary analysis using BAM indicated that there was a shift in diversification rates, including all Cape Verde Fissurella except the stem lineage. We didn't find any evidence of which is here represented by these red patches. And there, Cape Verde did not show any signs of increased diversification rates. So this already explains partially why Fissurella diversified much more than Cape Verde. As you can see here, this shift coincided with the Pleistocene boundary. And as you can see, after this boundary, the sea level dropped. And again, as within cone snails, the increased area available also promoted diversification within this group of gastropods. The fourth hypothesis of an earlier origin for Fissurella, which gave more time to accumulate species, was also verified by our data. As you can see here, the stem lineage of Fissurella originated roughly 3 million years earlier than Diodora, which may have allowed their dispersal to other islands of the archipelago and accumulate species. During this period, between 4.5 to 6.5 million years ago, there were severe episodes of volcanism in the island of Boa Vista, the only island where Diodora occurs. We think that these episodes may have caused major extinctions within this genus. These results are further corroborated by the long branches of the stem lineages of Fissurella and Diodora. As you know, long branches either mean increased diversification rates or high background extinction rates. As we've seen before, none of these lineage showed increased diversification rates, so the hypothesis of extinction seems more plausible. In summary, so our species limitation tests indicated 7 endemics within Fissurella and 1 endemic Diodora, so corroborated the morphological analysis. They did not agree in the number of non-endemics. The duration of the pelagical larval phase does not explain current species distribution, which is better explained by current patterns of ocean circulation that seem to favor and promote local retention. Fissurella originated 3 million years early, which gave her time for the group of dispersed other islands and speciate before the volcanic events that take place in Boa Vista, the only island where Diodora occurs. So Diodora was severely affected, we think, by these volcanic events. Also, low sea level drops observed during the Pleistocene boundary most likely promoted shifts in diversification rates by increasing the available shallow water habitat and promoting, creating additional opportunities for speciation. So these are all the people that were involved in these studies, and we have time for questions if you want. And you can see this cool movie about cone snails predation. These species eat fish, not the Cape Verde ones. That's why how they kill. They inject the venom and they swallow the fish. There is a question. There's a question? Oh, sorry.
Hello. Is Diodora lower in the intertidal than Fissurella species?
No, they occupy more or less the same habitat. No, there is no, like you can see the Regina, for instance, that they are in the same level of calm. Gretchen? Good.
So do you expect that, I mean, since the distributions were explained by current ocean by the currents,
Yes.
at
Mostly,
this time,
yes.
do you think that those currents have changed a lot over time since we're talking about the changes in the sea level and how that might affect our distributions?
They must not, we don't have data. These simulations only have 10 years, last 10 years of patterns of ocean circulation, because we can't move much further in time. We are talking about 6 million years ago. We believe that the patterns should be quite very different from these, otherwise we wouldn't have these kind of patterns. So we think they have, although there are lots of changes in the patterns and currents, I've been checking more or less what were the changes in the Atlantic, and most of the changes occurred when the Panama Seaway opened, more or less in this time frame, but it seems that might not affect it because Cape Verde is much further south, so it was the major change in the oceanic currents that got affected.